Okay, go ahead.
Hi, my name is Wanqing from BBS program. Today our topic is about cytoskeleton. We will talk about what cytoskeleton is and the things it does for cells, and also further application. Have you ever seen the scene in Harry Potter when the bone of Harry's arm is made to disappear? After that, Harry's arm is just flapping around like rubber. That's because without a skeleton, there is nothing to keep our shape intact. So our cells also need something like that to and also have something like that to maintain their shapes. That's the first function of cytoskeleton system. It's a highly ordered filamentous network in our cells, and also cytoskeleton is also very dynamic. So think about our skeleton. I could move by extracting my muscles and also my bones to make some specific actions so that our cell. In our cells, cytoskeleton could regulate cell migration and regulate the shape of cells by exerting some unique forces. So, speaking of cytoskeleton, here is a figure of it shows the fluorescence imaging of cytoskeleton in our cells. Here is the cell border, and here is the cell nuclei. The red and the green represents the two types of cytoskeleton in our cells. So, what the distribution of this filamentous cytoskeleton could remind you of in our real life?
I don't know. It's like a monster.
Don't you think it's a little like the distribution of the railway or highway in the country?
Oh yeah. Mm-hmm.
Yeah, that's it. So the third things that cytoskeleton could do to cell is to transport materials from one place to another for better reaction. So these things cytoskeleton does to cell is related to many important physiological processes, like the tissue development, like the wound healing, and also the tumor metastasis. So the research into cytoskeleton is of great significance for further clinical application. Actually, there is already one drug called paclitaxel, which is used in the treatment of many cancers. Its underlying principle is just related to cytoskeleton. It will stabilize the cytoskeleton system in cancer cells so that it can inhibit cancer cell activity. That's today's topic.
Oh, okay. Great, thank you. Thank you very much.
Any questions?
So, I can understand about the migration and the transportation, but I don't really quite understand how the cytoskeleton, for the first one, how does it maintain the shape?
You can think of when you have only flesh without bones in it, it will just be fluid. It's like water. It cannot keep a shape. We need a vase or some kind of container to make the water have a shape. So that's what cytoskeleton do. It's organized and also rigid, but it is regulated by other materials, so it's also dynamics. So that's one. It can maintain the shape. It can also change the shape to migrate.
Okay. And so is this how things like cancer, is this how they spread throughout the body? Is it through the cytoskeleton?
There are many related cellular processes. There are many cellular processes related to cells. The cytoskeleton is one of the most important because when cells move, when the tumor cells form, and then it needs to move to go into the further step. So if the cytoskeleton is inhibited, it cannot move very much. So it will not spread in your blood. So it will kind of inhibit the tumor formation.
You mean the medicine will inhibit?
Yeah.
Yeah, okay. But if you didn't have the medicine, then it would just spread throughout the whole body?
Yeah, that's the progress of whole cancer.
Okay. And how is this related to what you're working on, or is it not?
I'm working on some cytoskeleton related proteins. There are some proteins but can bind to microtubules. It can. I have talked about, in my poster session. I have the cytoskeleton and the molecules that can move the cargoes, move the materials from one place to another. That's pretty cool because when we can transport something, it's the neural activity is related to it, and also the transport. You can think of when there is no water in one place, you need to remove some water from the other water abundant places to save the people here.
Yeah.
Yeah, it's just like the process.
Okay, cool. Great, thank you very much.
Thank you.